right, here we're going to look at 2021 AP Calculus AB FRQ number 2. This is a classic motion problem. So it talks about a particle P moving along the x-axis and gives us the velocity function for that particle. And then they also tell us that at time t equals 0, particle P is at a position of x equals 5. So I'm going to go ahead and put a note here that x sub p of 0 is equal to 5. Okay, and then it also says the second particle q also moves along the x-axis. The velocity of particle q at time t is given by, it gives us a velocity function for particle q, and it tells us that at time t equals 0, particle q is at a position of x equals 10. So I'm also going to make a note for that. X of q of 0 is equal to 10. All right, so first question here says find the positions of particles P and particle Q at time t equals 1. Okay, so let's just go ahead and set these up first. So if I wanted to find x sub P of 1, well, what I would need to do here is I would need to put the initial position, so x sub P of 0, plus the accumulation of change, 0 to 1. And so I'm going to use an integral here to find that accumulation of change, and I'm going to find the integral of the velocity. Okay. And we already know that x sub P of 0 is equal to 5. Okay, so here's how I'm going to find my position for particle P at t equals 1. For particle Q, it's going to be very similar. I'm going to take my initial position at 0 and find the accumulation of change from 0 to 1 using the velocity function. Okay, and we were already told that the initial position for this was 10. Okay, so I want to make sure I set these up, so even if I do something wrong on the calculator, I can still get some credit for the right setup. But we'll notice here on my calculator, I already put in the velocity for particle 1 in y1 and the velocity for particle 2 in y2. I'm just going to double check those real quick if those are looking good. So let's start out with particle 1. So we got the initial position plus, and we want to find the integral from 0 to 1 of that velocity function. So that velocity function here is y1 for the first particle. So when I'm done here, I get 5.371. So I'll go ahead and make a note of that. 5.371. All right, and then we'll go down here and we'll do particle Q. So for this one, its initial position was 10. So we'll go integral from 0 to 1. This time I'm going to use y2 though, because that's where I saved that velocity. And when I'm done for this one, I get 8.564. Okay, 8.564. All right. So just to get a visual here, this means that particle Q is a little bit further to the right than particle P at time t equals 1. Okay. All right, let's go over to letter B. So it says, are particles P and Q moving toward each other or away from each other at time t equals 1? Explain your reasoning. Well, I just mentioned that at t equals 1, particle Q is somewhere over here, and then particle P is somewhere over here. We found that particle Q was at about, what do we get here, 8.5-ish, and then the particle P was about 5.4-ish, okay? So let's think for a second. In order to figure out if things are moving towards or away from each other, the first thing that we're definitely going to have to do is find their velocity. So let's start out by finding the velocity of P at 1 and the velocity of Q at 1, and then based on those answers, we can start to reason our way through whether they're moving towards or away from each other. So let's do that real quick. I'm just going to evaluate the first one here at 1, and then I'll evaluate the second velocity function at 1. I don't even particularly care what the numbers are here. I'll write them down, but I really just care about if they're positive or negative. So for particle 1, or for particle P, I get 0.841. Okay, so 0.841, and I'm also going to make sure I note that this is positive, although you don't have to write that, but just for emphasis. And then for particle 2, or for particle Q, I should say, the velocity is negative. Okay, so what does this mean? Well, if the velocity is positive, that means we're moving in the right direction. Okay, and if the velocity is negative, that means we're moving in the left direction. So just in my little sketch up here, if we think about particle P moving in the right direction, it means it's moving here. And then particle Q, since its velocity is negative, it's moving in the left direction, which means they're moving towards each other. Now we do want to wrap up our reasoning here, or summarize this. So we can say maybe for part A, we can see that at t equals 1, Q is further right than P. Okay. At t equals 1, velocity of particle P is greater than 0, so it's moving right. Okay, at t equals 1, velocity of Q is less than 0, so it's moving left. Okay, now that we've kind of stated all of our information here, now we can now say, therefore, P and Q are moving towards each other at t equals 1. Okay, it's a good summary of everything that's going on right there. All right, let's go over here to letter C. It says find the acceleration of particle Q at time t equals 1. Is the speed of particle Q increasing or decreasing at time t equals 1? Well, we know that in order for speed to be increasing, the velocity and acceleration have to have the same sign, and in order for the speed to be decreasing, the velocity and acceleration have to have different signs. From the last problem, we already figured out that the velocity of Q at 1 is negative 1, so I'm going to make a note here. VQ of 1 is equal to negative 1. So really we're looking for the acceleration. If the acceleration is negative, we know the speed is going to be increasing because the signs will be the same. If the acceleration is positive, the speed will be decreasing because we'll have opposite signs. We do need to make a note here that we have VQ of t. If we were to take its derivative, that would be equal to the acceleration of the particle. Okay, so we would like to state this so that a grader knows that we know this relationship here, and then we can go ahead and we can evaluate this acceleration. The calculator will do this for us, so let's ask the calculator to take the derivative of velocity of Q, which is what I saved in Y2. Oops, I'm sorry, messed up on my input right here. Okay, so the velocity of the derivative of 2, and we want to evaluate that at 1, and when we're done here, we see that we get 1.027, so okay, so 1.027. So now we can go ahead and make a concluding statement. Since at t equals 1, VQ of 1 is less than 0, and AQ of 1 is greater than 0, the speed of Q is decreasing. Okay, because these have opposite signs. Okay, so opposite signs indicate opposite signs for velocity and acceleration indicate a decreasing speed. All right, last but not least, we've got find the total distance traveled by particle P over the time interval from 0 to pi. Well, as long as you know how to set this up, this is a really, really easy problem. So to find a total distance, we find an accumulation of change from the beginning to the end. The only really important thing that you have to make sure you distinguish here is this is asking for total distance, which means we are going to take the absolute value of the velocity. So in this case, we're talking about particle P, so that's going to be V sub P of t dt. Okay, so I'm going to just plug this in directly into the calculator and get a final answer here when I'm done. Okay, so math 9. Okay, we're going from 0 to, be careful and make sure that you put your bounds in correctly, 0 to pi of absolute value. And we're talking about particle P, so that was where I saved in y sub 1. And let the calculator do the work here for us. And when we're finished, we get about 1.931. Okay, 1.931. So there's my total distance traveled by particle P over the time interval. Okay, and that wraps up question 2. Overall, not too bad of a question if you understand relationships between position, velocity, and acceleration.